So today we're going to look at climate change and particularly look at global warming and how that affects the idea of climate change. There's a bit of text in front of you and hopefully you'll be able to find it on your slides if you want. You can print it out if you want, or you can just kind of make notes as I go along. I'm going to highlight this bit of text that's on the screen in the areas that I think are really important, or anything that I think is really important. So if I highlight something, maybe you want to write it down as a note, or if you want to print it out and highlight it, or if you want to have it on a slide and highlight it, that's absolutely fine. All those options are available to you. Remember, you can pause the video at any point. If you need to pause the video, switch to the slides, highlight something, and come back, do that. So, climate change. Most scientists agree that global warming is occurring to the Earth, or on the Earth, and that it is caused by an increase in greenhouse gases. So it's caused by an increase in greenhouse gases, mainly carbon dioxide and methane. Okay? Thermal radiation from the sun hits the Earth, and most of it is reflected back into space. Greenhouse gases absorb this reflected radiation, increasing the temperature of the Earth by trapping it in the same way that a greenhouse works. Okay, so let's pick apart some of those words. So thermal radiation. Well, thermal means heat, and we've talked a little bit about that before, probably in physics or in chemistry, the idea of exothermic reactions or endothermic reactions. So thermal radiation, so the sun is giving off energy in the form of heat, and it hits the Earth, and most of it is reflected back into space. Now, reflected, think about like a mirror, so you're reflecting it back into space, it's bouncing back into space. But how do greenhouse gases affect this? Well, instead of it being reflected, greenhouse gases absorb this reflected radiation, so this reflected energy, and that increases the temperature of the Earth. Okay, so it increases the temperature of the Earth, and that might be an issue for us. All right, so we'll think about this in a minute. I'm going to have these kind of highlighted areas, and then we're going to go fill in a form, a kind of a pro forma for a graphic organizer together. Evidence for global warming, so we will start on this next paragraph. Evidence for global warming is based on lots of scientific research. So evidence, that's probably a key part of this paragraph. This is hopefully going to be one of our branches on our graphic organizer, the evidence for global warming. So it's based on scientific research, okay? And the scientific research, particularly global temperature changes compared to the amount of carbon dioxide in the atmosphere. There is a general correlation, and I'm going to highlight that word in a different colour because I want to think a little bit about what correlation means, between the temperature and carbon dioxide concentration as shown on the graph on the right. We'll have a little look at that graph together. We'll zoom in and have a little look in a second. But first of all, what does correlation mean? So correlation means kind of a pattern. Let's put it down here. So correlation. Correlation in science or in maths kind of means a link. So as one thing goes up, so as A goes up, B goes up, or maybe as A goes up, B goes down. So it's a link between two variables, two kind of factors, in this case temperature and carbon dioxide in the atmosphere. There's some sort of link between those two things that you can see, particularly normally in science, you can see it on the graph. So let's have a little zoom in over here. This graph is very blurry from what I can see. So we have on the y-axis, so on this left-hand side, we have the amount of carbon dioxide in the atmosphere. Okay, and on the axis on the right-hand side, we have the temperature, the same y-axis. So this is a slightly strange graph because it's got two y-axes, and that's because there's two different lines. So the red line is the global average temperature, and the blue line is the amount of carbon dioxide in the atmosphere. So let's try and follow this along. So what happens to the temperature between this time, I think that's 1964, I think that says, and 2008. So what happens to the temperature? Well, this red line is going up and down, but actually, overall, if we were to smooth this line out, we can see that it starts off somewhere around, the change in global temperature has started off somewhere around 0.2 degrees, and it has increased slowly all the way up to maybe 0.5, 0.6 degrees at the top. So this is slowly increasing. Now, although it varies year by year and month by month, although this line kind of wobbles its way up, it is still overall going up. And the carbon dioxide parts per million is much easier to see. So it starts off quite low down here and it slowly increases. There's the odd little dip here and there. And you can see how these two graphs kind of line up really quite nicely. So as the amount of carbon dioxide in the atmosphere has gone up, so has the global temperature. And this is possibly the best piece of evidence for global warming and the idea of climate change, particularly that it's caused by man-made issues. Because this down here, this sort of period, when we start to see more and more cars, more and more modes of transport, planes, slowly getting higher and higher, and in the last sort of 20 years increasing even more. So we need to really think about what's going on here, and scientists have started thinking about what's going on here. So we'll go back out to here so we can see it, and we will have a look together at these last couple of paragraphs. So we're definitely going to think about this graph in a minute. We might even draw out a version of that graph. There are some groups of people who deny that climate change or global warming is caused by human activities. So these are our deniers. There are people who deny that it's caused by human activities. And there's lots of reasons for this, but partially this is due to the fact that modelling climate systems can be very complicated. So modelling means kind of predicting them, suggesting why they're happening. It can be very complicated, so it can be very difficult. This leads to simplified models, so we make it simpler, okay? Being presented as an alternative that are only based on parts of the evidence. So that means they don't account for all the evidence, they don't account for all the science, they are kind of partially complete models. And that means people can find issue with them and find problems that they call out on them. Scientific opinions about climate change are based on peer review. Now, this is something we are going to think a little bit more about. This is an important term that we need to know a little bit about. Scientists, and what it is, and it's given in the next sentence, is scientists publish their ideas and research in journals. And journals are like a bit like a science magazine, if you think of it like that. They're science magazines made for scientists. So you have your article about what you've been doing, your research, and you publish it in a journal, a bit like you would pick up a newspaper or pick up a magazine, which are then reviewed by equivalent experts. Now, this is the important bit about peer review. So the same way you guys might peer mark, you look at each other's work, scientists peer mark, and they call it peer review. So they will put out, before their article gets put into the journal, into their magazine, essentially, it gets put to other scientists first, who will look at all the evidence that that person's gathered and decide whether they agree with that person. If they agree with that person, then they can be published and they become an accepted theory in science. Okay, and a theory is like an idea about how it works. So it's really important that you've got these other experts checking on other scientists' work. Now, why are we interested in global warming and climate change? Why does it matter to us, particularly at school and to you guys at home? So global warming will lead to climate change, and the effect of climate change could include lots of things, but we've picked out a few of them for you here. So it could include more freak weather events. That means more strange weather, okay? More thunder and lightning in the middle of the summer, or snow in June. Very strange weather, freak weather events. It could include more intense or damaging storms. One that we should be worried about in our local area is rising sea levels, because if the sea gets higher, more and more of our area is going to end up underwater. It could lead to habitat destruction. That means destroying the areas that animals live in, and problems with growing food on farmland, which would upset me greatly if I couldn't get hold of all of my food. Okay, so there's problems with growing food on farmlands. So we've taken a little bit of time. I know it's been nearly 10 minutes picking this apart, but I think it's really important that we pick it apart, and we're going to go and have a look at putting this information onto a graphic organizer now. So we're going to have a look at this little graphic organizer, and we've partially filled in a few of the boxes for you to give you a bit of an idea. So we've got 4 branches here. We've got evidence for climate change denied by some people and what that's due to, scientific opinion and what it's based on, and the effects of climate change. And I've actually put just over to this size the highlighted notes so that we can fill this in together. So let's start somewhere where we know where we're going. So for instance, can we see that here it says evidence for climate change, and actually over here this whole paragraph is evidence for global warming and climate change. So why don't we start there and see whether we can kind of match up what should go in the boxes. So I'm going to move myself back over to look just at the evidence for climate change, and then we're going to start filling it out. I don't know if that'll be a bit small, but we'll see how that goes. Okay, so evidence for climate change is based on what? Well, evidence for global warming is based on lots of scientific research. So let's try scientific research. We can always come back and edit this in a moment. So it's based on scientific. It's based on scientific research. I think that's probably what goes in that box there. Now remember, you can do it on your tablet. Sorry, not on your tablet. You could do it on your slides, or you could do it on your piece of paper, however you want to do it. But you should put scientific research in that box there. Probably a little bit small. So what I'm going to do is I'm going to zoom in over there so that you can see this branch, and then I will switch backwards and forwards. Okay. Particularly, well, if you look back at your paragraph where we were just looking, so if you look back at the paragraph we were just looking, evidence for global warming is based on lots of scientific research, particularly global temperature changes compared to the amount of carbon dioxide in the atmosphere. So, particularly global temperature changes versus the amount of carbon dioxide in the atmosphere. So, global temperature versus the volume of CO2 gas, carbon dioxide, CO2 in the atmosphere. Okay, that's our first branch done. And if you kind of follow along, you've got evidence for climate change, scientific research, evidence for climate change is based on scientific research, particularly global temperature versus the volume of CO2 in the atmosphere. And I would recommend that as a way to help learn this. So once you're done filling in your little graphic organizer, once you're done filling in your sort of mind map, is to take a few minutes just to follow it around with your finger and read it. So literally put your finger on the page. I'm doing it with my pen for my tablet in a minute. Evidence for climate change is based on scientific research, particularly global temperature versus the volume of CO2 in the atmosphere. Now we're going to fill in the rest of this. And actually, you could pause this video now and you could spend a bit of time trying to fill in as much of this as you can before we have a look at the rest of them. And in fact, I might fill in the rest of them and then project it back up so that you can have a look. So make sure you follow along, you read through the text carefully, and you see whether you can fill this in. So pause here. Take some time, read through the text to add in and finish off this mind map, this graphic organizer. Pause right now, do it, and then come back and we will go through the answers. So here is the completed mind map for you to have a look at. So let's just follow it around one time. Like I said, so climate change, and I want you to do this several times. I'm going to do it once. Evidence of climate change is based on scientific research, particularly global temperature versus the volume of CO2 in the atmosphere. Climate change is denied by some people due to simplified models, which leads to partial evidence. Climate change is based on scientific opinions, which are based on peer reviews. And the effects of climate change, potentially, there are 5 effects here that you could have, are more freak weather events, more damaging storms, rising sea levels, habitat destruction, and food supply issues. And I really do mean it when I say I want you to do that same process at least another 3 times. Okay, so go around that mind map 3 times. Your one on your page, follow it around your finger, follow it around with a pencil, follow it around at least 3 more times, because it really will help you to get that information into your head. Once you've done that, I want you to stop this video, go back to your slides, and on there you'll find several drill questions, practice questions for you that are based exactly on this mind map. So if you get stuck, make sure you look back at this mind map because it has all of the answers on it.